Right now, far beyond the planets, beyond sunlight, beyond everything we've ever touched, drifts a small machine built nearly half a century ago. A machine no bigger than a small car running on the power of a refrigerator bulb. And yet, it is the most distant object humanity has ever created. Voyager 1, launched in 1977, still talking to us today. Across 26 billion kilometres it whispers home with a signal so faint it carries less energy than a falling snowflake. So here's the question. Almost nobody asks, why hasn't Voyager hit anything? No asteroids, no comets, not even a piece of dust big enough to matter. How can it drift for nearly 50 years without a deadly collision? To answer that, we go back to the moment humanity lit the fuse, sending Voyager on a journey that would outlive its creators. September 5th, 1977, Cape Canaveral. Humid morning air. A Titan 3D rocket towers above the pad with Voyager 1 at its tip. The mission: explore Jupiter, explore Saturn, send back photos no one had ever seen. 5 years, a simple tour. Nobody imagined it would leave the solar system or survive for decades. When the engines ignited and the rocket climbed, Voyager began a journey that would carry it farther than any spacecraft in history. A machine built in the age of typewriters and rotary phones became our silent ambassador to the galaxy. Hollywood lied, space isn't crowded. The asteroid belt isn't a chaotic minefield, it's vast and nearly empty. The average distance between large asteroids is over 1 million kilometres, like standing in a desert and seeing one grain of sand a kilometre away, and the farther you go, the emptier space becomes. Even the Kuiper belt is mostly isolated ice spread across billions of kilometres. Space is a desert so enormous that Voyager could travel for centuries without touching anything solid. That emptiness is why it's still alive. But there was one terrifying moment when Voyager nearly died: Saturn. Its rings are made of ice, dust and broken moons, some tiny, some mountain-sized. To get the gravity assist, Voyager had to cross the ring plane, where particles move at deadly speeds. A pebble would strike like a bullet. A baseball-sized rock could tear the spacecraft apart. NASA found a narrow, low-density lane and threaded Voyager through it, like threading a needle from thousands of kilometres away at 15 kilometres per second. Voyager survived barely. Even today, microscopic dust taps its shielding, but it was built to endure. Voyager transmits with just 23 watts, a dim light bulb. By the time the signal reaches Earth, it's weaker than a whisper buried in cosmic noise. We hear it using the Deep Space Network, giant 70-metre antennas in California, Spain and Australia. They can detect a watch ticking across a continent. Voyager points its dish at Earth. Earth points back. In that faint stream of photons is everything it can tell us: temperatures, particle density, magnetic fields. Each whisper takes over a day to arrive, but we still hear it. Voyager has left the solar system. It crossed the heliopause, the boundary where the sun's influence ends, and entered true interstellar space. Out here, the particles it measures are older than Earth, ancient cosmic rays and ions drifting between stars. The medium is thin, like a few grains of dust in a cathedral-sized volume. Voyager is the first spacecraft to sample this region directly. Every reading it sends home is human history from a place no creature has ever seen. Attached to Voyager is one of humanity's most beautiful creations, the Golden Record. A gold-plated copper disc containing our languages, music, mathematics, DNA, greetings, and sounds of Earth, Waves, thunder, a heartbeat, even a mother kissing her child. It also carries photographs of our world and our faces. If anyone ever finds Voyager, they'll find this record, a frozen moment of who we were, a map to Earth, a message saying, we were here, and this is what we loved. Voyager's power is fading. By the mid-2030-50s, its instruments will shut down. Eventually the radio will fall silent. The antenna will go dark. But the journey won't end. Long after Earth has changed, long after our constellations shift, Voyager will still be moving outward. In 40,000 years, it will pass near a faint red dwarf, Gliese 445. It won't slow down or turn. It will simply drift on, carrying a golden record, carrying us. In a galaxy of 100 billion stars, Voyager becomes a single grain of metal sailing through eternity. Voyager didn't survive by luck. It survived because space is vast and almost empty, because its engineers built it tougher than they ever needed to, because humanity dared to reach beyond the horizon. And somewhere in the dark between the stars, that little machine still drifts, carrying a message from a small blue world that wanted to say, hello,